Does it look any different to any narrow-body plane that you've used to fly?
So welcome on board China's new airplane. There's so many other aviation enthusiasts come on board the Comac C919.
The commercial aviation industry has been a closed club for decades. Two Western giants have split the market between them, setting prices, defining standards, and controlling the future of air travel. But China has been quietly building something that could reshape that entire equation. A wide-body aircraft that aims to fly as far, carry as many passengers, and cost significantly less than anything Boeing or Airbus currently offers. The question isn't whether China can build it. The question is, what happens to the industry when they do? The duopoly that ruled the skies. For nearly half a century, if an airline wanted a wide-body aircraft, they had exactly two phone numbers to call: Boeing in Seattle or Airbus in Toulouse. This wasn't just market dominance. It was a complete lock on the technology, supply chains, and regulatory frameworks that make long-haul aviation possible. The Boeing 747 revolutionized air travel in the 1970s, making intercontinental flights accessible to millions. Airbus answered with the A300 and eventually the massive A380. But competition between these two never really translated into lower prices for airlines. When you only have two suppliers for something as complex as a wide-body jet, they set the terms. Aircraft prices climbed steadily, delivery slots stretched years into the future, and airlines had little leverage. Attempts by other countries to break into this market failed repeatedly. Russia's wide-body programs never achieved commercial viability. Japan's involvement in Boeing production remained as a junior partner, not an independent manufacturer. The barriers were simply too high. You needed decades of experience, thousands of certified suppliers, engine manufacturers willing to work with you, and regulatory bodies willing to certify your aircraft for international operations. Most importantly, you needed customers willing to bet their business on an unproven product. The Boeing-Airbus duopoly wasn't maintained through conspiracy. It existed because building safe, efficient, long-range aircraft is extraordinarily difficult, and these two companies had spent decades perfecting it. Comac's journey from ambition to reality. China established the Commercial Aircraft Corporation of China, known as Comac, in 2008 with a clear mission: build aircraft that could eventually compete globally and reduce dependence on Western manufacturers. The company's first major project, the ARJ-21 regional jet, took longer than expected and faced numerous certification hurdles. But it taught Comac invaluable lessons about aircraft development, certification processes, and the complex web of suppliers needed for modern aviation. The real test came with the C919, a narrow-body aircraft designed to compete with the Boeing 737 and Airbus A320. Development began in earnest in 2008, with the first flight finally happening in 2017. After years of testing and certification challenges, the C919 entered commercial service with China Eastern Airlines in 2022. The aircraft works. It flies passengers safely on domestic routes. But the C919 also revealed the immense challenges China faces. Despite being a Chinese aircraft, it relies heavily on Western components. The engines come from a CFM international joint venture. Avionics, flight controls, and numerous other systems come from American and European suppliers. This dependency became a political vulnerability when trade tensions rose. More importantly, the C919 demonstrated that building a narrow-body, which is relatively simpler, took China nearly 15 years from program launch to commercial service. A wide-body aircraft is exponentially more complex. The wings are larger and must flex more under stress. The fuselage needs to maintain pressure over longer flights. The range requirements demand better fuel efficiency. Every system needs redundancy because you're flying over oceans for hours with no emergency landing options. Comac learned from the C919 experience, but the C929 represents a completely different category of challenge. The C929's design and specifications. The aircraft China is developing isn't a modest first attempt. The baseline C929 is designed for 280 passengers in a 3-class configuration, with variants planned to accommodate anywhere from 250 to 400 passengers, depending on airline preferences. The target range sits at approximately 12,000 kilometers, enough to connect Beijing with London or Shanghai with Los Angeles. These specifications put it directly in competition with the Boeing 787 and Airbus A350, the most advanced wide-body aircraft currently in service. The design philosophy borrows heavily from modern aviation trends. Composite materials will make up over 50% of the primary structure, reducing weight and improving fuel efficiency. This is similar to the approach Boeing took with the 787, where carbon fiber composites replaced traditional aluminum in much of the airframe. The wings, fuselage sections, and tail structures all incorporate these advanced materials. The engineering challenges here are substantial. Composites behave differently than metals under stress, require different manufacturing processes, and demand new inspection techniques to ensure safety. The twin-engine configuration follows the industry standard for modern long-haul aircraft. Four-engine jets like the 747 and A380 have fallen out of favor because modern engines are reliable enough that twin-engine aircraft can safely fly long overwater routes while burning significantly less fuel. The C929's aerodynamic design includes features like raked wingtips and optimized fuselage shaping to reduce drag. Inside, the cabin is designed with wider seats and overhead bins sized for modern carry-on luggage. Airlines will have flexibility in configuring everything from all-economy layouts to premium-heavy configurations with lie-flat business-class seats. On paper, the C929 matches its Western competitors in almost every specification. The challenge isn't designing an aircraft that looks competitive. It's building one that actually performs as promised, passes certification, and operates reliably for decades. The Russian partnership that wasn't. When the C929 program launched in 2017, it wasn't a solely Chinese project. Russia's United Aircraft Corporation partnered with COMAC in a 50-50 joint venture, creating what was then called the CR929. The partnership made strategic sense for both countries. Russia brought decades of experience building large aircraft, including wide-body designs like the Il-96. China brought manufacturing capability, a massive domestic market, and funding. The plan called for final assembly lines in both countries, with each nation's aviation industry contributing components and expertise. The division of work seemed logical. Russia would handle wing design and some fuselage sections, leveraging its experience with large aircraft structures. China would lead on avionics, interior systems, and final assembly for the Asian market. Both countries would benefit from breaking Western dominance in wide-body manufacturing. For several years, the partnership progressed through preliminary design phases. Mock-ups appeared at international air shows. Engineers from both countries collaborated on specifications. Then, geopolitical reality intervened. Russia's invasion of Ukraine in 2022 triggered unprecedented Western sanctions that crippled its aviation industry. Russian airlines lost access to Boeing and Airbus aircraft, spare parts, and technical support. The country's own aircraft programs faced supply chain disruptions as Western component suppliers withdrew. By 2023, the partnership collapsed. Russia officially withdrew from the joint venture, and the aircraft was renamed simply the C929. The reasons extended beyond sanctions. China apparently concluded that the partnership was slowing development and that Russia's contribution, while valuable, wasn't essential enough to justify the complications. Going solo meant China controlled all decisions, timelines, and technology, but it also meant shouldering the entire development burden and risk. The breakup revealed something important about China's confidence in its aviation industry. They believed they could complete a wide-body aircraft program independently, something no country had successfully done in decades, where the C929 actually stands today. Despite sensational headlines suggesting imminent test flights, the C929 remains in relatively early development stages. As of late 2025, the program is in detailed design phase, where engineering teams finalize specifications for every component and system. This phase comes before any metal gets cut or composite materials get laid up for actual aircraft structures. In November 2024, COMAC announced a framework agreement with Air China, establishing the state-owned carrier as the launch customer. This matters enormously for the program. Having a committed customer, especially one as significant as Air China, validates the design and provides concrete operational requirements to design around. Airlines don't just buy aircraft, they specify everything from galley locations to cargo hold configurations, and incorporating these requirements early prevents costly changes later. Current timelines, based on statements from suppliers and industry analysts, point to first fuselage sections being delivered around September 2027. These aren't complete aircraft, but major structural components that will eventually be assembled into a prototype. If that timeline holds, a complete prototype might exist by 2029. First flight would follow months or years later, depending on how assembly and ground testing proceed. Certification represents another massive hurdle that typically takes 3 to 5 years after first flight. The aircraft must prove it can handle every conceivable situation, from engine failures to extreme weather to system malfunctions. Chinese certification might come relatively quickly given government support. International certification from the FAA and EASA, which airlines outside China will require, takes much longer. Realistic estimates from aerospace analysts suggest the C929 might achieve certification around 2032, with commercial service beginning in the early to mid-2030s. This isn't failure or delay by aircraft development standards. The Boeing 787 took about 8 years from program launch to first delivery, and that was with Boeing's decades of wide-body experience. The Airbus A350 followed a similar timeline. COMAC is attempting something harder with less experience, so a 15-year development timeline is actually reasonable. The engine problem. Nobody talks about. Every discussion of the C929 eventually arrives at the same uncomfortable reality. The engines, high-thrust turbofan engines capable of powering a wide-body aircraft across oceans, represent some of the most complex technology humans manufacture. Only a handful of companies worldwide can build them. General Electric, Rolls-Royce, and Pratt & Whitney dominate the market, with some collaboration through joint ventures like CFM International. China has invested heavily in developing domestic engine technology through programs like the CJ2000, specifically designed to power wide-body aircraft. But developing an engine isn't like scaling up existing technology. The thermodynamics, materials science, and manufacturing precision required increase exponentially with engine size and thrust requirements. Turbine blades must withstand temperatures exceeding the melting point of the metals they're made from, relying on sophisticated cooling channels and ceramic coatings. The entire engine must run reliably for thousands of hours between overhauls while maintaining strict fuel efficiency standards. The CJ2000 program has faced repeated delays. As of 2025, no clear timeline exists for when a fully certified Chinese-made engine will be ready for the C929. This creates a dependency problem that undermines the entire goal of aviation self-reliance. COMAC could theoretically use Western engines, and some variants might do exactly that. Rolls-Royce and other manufacturers have shown interest, recognizing the massive Chinese market. But this brings political risk. If relations between China and Western countries deteriorate, engine supplies could be cut off, grounding the fleet. The C929 already faces this vulnerability, as it relies on CFM LEAP engines. Trade restrictions have complicated C919 international sales because the American component requires U.S. export approval. The C929 could face identical problems, but on a larger scale. Without a domestic engine option, China's wide-body ambitions remain dependent on the very Western suppliers they're trying to compete against. This tension defines much of the C929's development challenge. China's domestic market advantage. While Western certification and international sales matter, eventually, China possesses something that changes the equation entirely: the world's largest and fastest-growing aviation market. Chinese airlines carried over 400 million passengers domestically in recent years, a number that continues climbing as the middle class expands. The country needs hundreds of new wide-body aircraft over the next 2 decades just to meet domestic demand. International routes connecting Chinese cities to destinations across Asia, Africa, and beyond add to this requirement. This captive market provides COMAC with a massive advantage Boeing and Airbus never enjoyed. Even if the C929 never sells a single aircraft outside China, the domestic market alone can sustain the program. Chinese airlines, many state-owned or state-influenced, can be directed to purchase C929 aircraft, regardless of whether Western alternatives might be slightly more efficient or proven. This guaranteed customer base eliminates the single biggest risk in aircraft development, which is spending billions on a program only to discover airlines won't buy it. Government support extends beyond just purchasing aircraft. Chinese banks offer favorable financing terms to airlines buying COMAC products. Regulatory approval happens faster. Infrastructure investments at airports accommodate new aircraft types. The entire system is oriented toward making domestic aircraft successful. This isn't unique to China. Boeing benefited enormously from U.S. military contracts and government support throughout its history. Airbus was literally created through government collaboration among European nations who wanted a competitor to American dominance. What differs is the scale and directness of support available to COMAC. The domestic market advantage also provides operational data that will be crucial for improving the aircraft. Early versions will inevitably have issues that need refinement. Having hundreds of aircraft flying millions of hours on Chinese routes generates the data needed to identify problems and develop solutions. By the time COMAC seriously pursues international certification, the C929 will have extensive real-world operational experience, making it a more mature and proven product. The certification mountain to climb. Getting an aircraft certified to carry passengers is arguably harder than designing it in the first place. The process involves proving to regulatory authorities that the aircraft meets thousands of specific requirements, covering everything from structural strength to emergency evacuation times. In China, the Civil Aviation Administration of China handles certification. Given government priorities around developing domestic aviation, CAAC certification will almost certainly be achieved, though not without extensive testing. The real challenges are the FAA in the United States and EASA in Europe. These agencies set standards that most of the world follows. Airlines in Asia, the Middle East, Africa, and Latin America typically require FAA or EASA certification before purchasing aircraft, even if they never fly to the US or Europe. Without these certifications, COMAC's international market shrinks dramatically. The certification process takes years and involves detailed review of design documents, inspection of manufacturing processes, and extensive flight testing. The aircraft must prove it can handle every conceivable failure mode. What happens if one engine fails during takeoff? What if multiple systems fail simultaneously? How quickly can passengers evacuate in an emergency? Every scenario must be tested and documented. Political complications add another layer. The FAA spent years scrutinizing the C919, and certification for U.S. operations still hasn't been achieved as of 2025. Relations between the U.S. and China have grown more tense, not less, since that process began. The C929 will face even greater scrutiny as a wide-body aircraft with more complex systems and higher passenger capacity. Some aerospace analysts believe full FAA certification for the C929 might never happen, or might take a decade or more. EASA historically follows similar timelines. This doesn't doom the aircraft, but it does limit where it can fly. Airlines in countries with strong ties to China might accept CAAC certification alone, especially if COMAC offers attractive pricing. But major international carriers in Europe, the Americas, and parts of Asia will likely wait for Western certification before placing orders. What this means for the aviation industry. Whether the C929 becomes a global success or remains primarily a Chinese aircraft, its existence changes the competitive landscape. For the first time in 50 years, Boeing and Airbus face a potential competitor with deep pockets, government backing, and access to a massive market. The immediate impact will be felt in pricing and sales strategies. If Chinese airlines shift significant orders from Boeing and Airbus to COMAC, both Western manufacturers lose a crucial growth market. China represented one of their largest customer bases for wide-body aircraft. Those sales might not disappear entirely, but they'll shrink. This forces Boeing and Airbus to compete more aggressively in other markets, potentially lowering prices or offering better financing terms. The longer-term implications are more profound. COMAC will learn from every aircraft delivered, every hour flown, and every problem solved. The C929 might be less efficient or capable than the 787 or A350 initially, but aircraft programs improve continuously. Boeing's 737 has been refined over decades into something vastly more capable than the original 1960s design. The A320 family evolved similarly. Give Comac a decade of operational experience, and the C929 might become genuinely competitive on performance, not just price. Technology transfer concerns add geopolitical tension. Western suppliers providing components or expertise to Comac face criticism that they're helping China develop capabilities that might eventually be used against Western interests. The U.S. government has already restricted some technology exports to Chinese aviation companies. These restrictions might tighten further, forcing Comac toward complete self-reliance faster than planned. The aviation supply chain might fracture into Western and Chinese ecosystems with limited overlap. For airlines, a viable third option for wide-body aircraft would be enormously valuable. Duopolies are terrible for customers. Having Comac as a credible alternative gives airlines leverage in negotiations with Boeing and Airbus, potentially lowering costs even for carriers who never buy a C929. Smaller or developing nations might particularly benefit. China has shown willingness to offer favorable financing and political relationships as part of aircraft sales, something Western manufacturers can't or won't always match. The C929 won't revolutionize aviation overnight. No prototype exists yet, and the path to certification remains long and uncertain. But the program represents something genuinely significant. China is methodically building the expertise, infrastructure, and supply chains needed to compete in the most complex and politically sensitive manufacturing sector in the world. Whether the C929 succeeds commercially or struggles with technical challenges, China will learn from it, and they'll apply those lessons to the next aircraft and the one after that. The aviation industry's closed club is opening, whether the current members like it or not.